This question is asked in Kerala PSC lecturer in Polytechnic Electronics 2021. A matrix X has A plus B rows and B plus 1 columns, while matrix Y has A minus 2 rows and A plus 2 columns. Both matrix XY and YX exist. Then A and B are. Here we have A plus B rows in the first column, sorry, first matrix, and B plus 1 columns in the first matrix. That is for matrix X. Okay, and for matrix Y, we have A minus 2 rows and A plus 2 columns. Okay, now we know if matrix X into Y exists, it means the number of columns in X and number of rows in Y must be same, which means we will get B plus 1 equal to A minus 2. Similarly, Yx also exists. It implies the number of columns in Y, which is A plus 2, must be equal to number of rows in X, which is A plus B. Okay, so from the second relation you can easily get B is equal to 2 and substitute that in the first relation, which will give you A is equal to, actually it is B plus 1 plus 2. So B is already 2, so the answer is A equal to 5 and B equal to 2. So option A is the correct answer. In this question, the value of the determinant 1, 2, 3, 3 to 5 and k to 4 is given to be 0, and you are asked to find out what is the value of k. You can do the conventional way of calculating the determinant, or another easier way is, if the columns of the matrix are linearly dependent, then the determinant must be equal to 0. Here if you check column 1 and column 2, you can see column 3 is 1 plus 2 equal to 3, 3 plus 2 equal to 5. So k plus 2 must be equal to 4, and hence k must be equal to 2 for the columns to be linearly dependent. So that should be the value which will give determinant equal to 0. Hence answer C is the correct one. Okay, in this question, it is given C0, C1, C2, etc. denote the coefficients in the binomial expansion of 1 plus x whole raised to n. Then C0 square plus C1 square plus C2 square, etc. Cn square equal to. Now, actually, to prove this relation, it takes a lot of time. So, in an examination hall, the easiest way to solve it is by substituting for simple values of n. For example, if you put n is equal to 2, we know the binomial coefficients are 1, 2, and 1, right? So the coefficient squares will be 1 square plus 2 square plus 1 square, which will give you the answer as 6. Now you put n is equal to 2 here, that will be 4 factorial divided by 2 factorial whole square, right? So that's equal to 4 into 3 into 2 divided by 2 factorial is 2, that whole square will be 4. So you get the answer to be matching, but we cannot conclude that answer is correct because we have to check whether B, C, D are also giving the correct answer. When you put n is equal to 2 here, that will be in option B, that will be 2 square into 3 divided by 2 factorial, correct? So that is also giving you the answer as 6. So A or B can be the answer. Now you check C. That will be 2 into 3 into again 2 raised to 0, which is 6. Option D can be cancelled out with n value 2. Now if you check n value 3, if you put n is equal to 3, we know the coefficients are 1, 3, 3 and 1, right? So the sum of squares of these coefficients will be 1 plus 9 plus 9 plus 1, which is equal to 20. Now you put for n equal to 3 here, that will be 6 factorial divided by 3 factorial whole square, right? So that is equal to 6 into 4, 5 into 4 into 3 factorial divided by 3 factorial square, right? So 1 3 factorial can be cancelled out from here. So you'll get 6 into 5 into 4 divided by 3 factorial is 6. So you can cancel out 6 and 3 factorial. So the answer is 20. See, option A is matching for n is equal to 3 also. Now you check for n is equal to 3 here. This will be 2 raised to 3, which is 8 into 4, correct? 8 into 4 is 32. 32 divided by 3 factorial. You know that is not going to be 20. Now you check for option C. 3 into 4, 12 into 2, which is 24. That is also right. So we know option B and option C are wrong, and you can easily choose option A as the correct one. Right, in this question, 2 tan inverse 1 plus tan inverse 2 plus tan inverse 3 is equal to. That is the question. Okay, so I can write it as 2 tan inverse 1 plus the second angle I have assumed it to be A, third angle I am assuming it to be B. This is what is required, right? Okay. So I know tan inverse 1 is pi by 4. So 2 into pi by 4 is pi by 2, correct? So pi by 2 plus A plus B is what is required, right? Now, if I take tan of this, then tan of pi by 2 plus, sorry, tan of pi by 2 plus A plus B will be equal to tan of 90 plus theta is cot theta. So that I can write minus cot theta. So that I can write as minus cot of A plus B, correct? So that is equal to minus cot is actually 1 by tan. So 1 by tan of A plus B. Okay. Now I expand tan of A plus B here. So I'll get minus 1 divided by tan of A plus B is tan A plus tan B whole divided by 1 minus tan A into tan B. Okay. And from the given angles, I know A is tan inverse 2. So what is tan A? Tan A will be 2. B is tan inverse 3. So what is tan B? Tan B will be 3. So I can write this is equal to minus 1 divided by 2 plus 3 divided by 1 minus 2 into 3. You can see 2 plus 3 is 5. 5 divided by minus 5 is minus 1. Minus 1 by minus 1 is 1. Okay. So I am getting this is equal to 1. Correct? Now, this is equal to 1 implies what is the answer? Now, what we got is tan of some angle is equal to 1. So, what should be this angle? That angle must be equal to pi by 4, right? That angle must be equal to pi by 4. And that is the option B, which is the correct option. Okay. In this question, the foot of the perpendicular from the point 2, comma 3 to the line 2x plus y minus 3 is asked. So first, the slope of this line, which is y is equal to minus 2x plus 3. We all know the slope of that line is minus 2. Okay. Now, any line which is perpendicular to this line, if its slope is m, then the product of the slopes of these two lines must be equal to minus 1. That is the condition for perpendicularity. Hence, the slope of the required line is easily, you can write it as 1 by 2. So, now the perpendicular line will have slope 1 by 2. So, I can write that line as y is equal to 1 by 2 x plus c. Now, that line must be passing through this point, right? 2 comma 3. So, if you substitute those values, 3 is equal to 2 by 2 plus c, which means I will get c is equal to 2. So now I got the line which is y is equal to x by 2 plus 2, and that line must be meeting this particular line. So I can substitute 2x plus y instead of y. I am substituting this line. So 2x plus x by 2 plus 2 minus 3 must be equal to 0. And from here I will get 5x by 2 equal to 1, and the x coordinate should be equal to 2 by 5. Now you can check for the y coordinate again by substituting this value. So x coordinate is 2 by 5, which means in this line, if you put x equal to 2 by 5, that will be 4 by 5 plus y minus 3 equal to 0. So y is equal to 3 minus 4 by 5. So that is 15 minus 4, 11 by 5. So your x value is 2 by 5, y value is 11 by 5. Now option D is the correct one. Okay. In this question, a calculus question is given to you. Limit h tending to 2, h raised to n minus 2 raised to n divided by h square minus 4 is given to be 20. and you are asked to find out the value of n. It is given n is a positive integer. So we know if you put substitute x equal to 2 in this equation, we'll get 0 by 0 form, because 2 raised to n minus 2 raised to n will be 0, and 2 square will be 4 minus 4, again 0. So if you have something in the form of 0 by 0, we need to go for the L'Hospital's rule, that is differentiate in the numerator, you will get n x raised to n minus 1, okay, and the denominator, if you differentiate, it will be 2x, right? Now you put limit x tending to 2, okay, what you get as the answer will be n into 2 raised to n minus 1 whole divided by 2 into 2, which is 4, right? And this is given to be 20, correct? So I can write n into 2 raised to n minus 1 equal to 4 into 20, which is 80. And easily you can substitute the value of n here. So if you check, you'll get n is 5 is the correct answer, because 3 into 2 raised to 3 minus 2 is not equal to 80, but 5 into 2 raised to 5 minus 1 is equal to actually 5 into 2 raised to 4, which is 5 into 16 equal to 80. So the value of n here is 5. That is the correct answer. Slope of the normal to the curve y is equal to 2x cube at the point whose x coordinate is 2. So if you want to find the slope of normal to the curve, first you differentiate the curve, okay, which is y is equal to 2x cube. If you differentiate the curve, you will get 6x square, okay, and at the point x equal to 2, at the point x equal to 2, the value of this slope is equal to 6 into 4, which is equal to 24, okay. But this 24 value is the slope of tangent to the curve, okay, and the product of slope of tangent and normal must be equal to minus 1. So if I assume the slope of normal is m into 24 must be equal to minus 1, correct, because this is the slope of tangent and this is the slope of normal, right? So you will get m is equal to minus 1 by 24. So the correct answer is option B. Okay, in this question, the value of integral x minus 1 by x square into e raised to x dx is asked. But if we directly evaluate the integral, we need to apply integration by parts. So it is very difficult to do this problem in that way. The best option is to get the answer from options. If you think about the options, which options derivative will give the function which is given inside the integral? That is what we need to check. So if you think about the u by v form of functions, the derivative of u by v, when you take d by dx of u by v, we need to take it v into du by dx minus u into dv by dx whole divided by h square. Sorry, whole divided by v square. So when I think about this v square, the v square term is correspondingly h square here. So naturally v must be h, right? So when I look at the options, the fourth option has got denominator as h. Now we'll check whether that is correct. So v is h. So h into d by dx of e raised to x is e raised to x minus e raised to x into d by dx of x is 1 whole divided by h square, right? So that is equal to e raised to x into x minus 1 whole divided by h square. Now this is the exact function which is given inside the integral. So our option is option 4, e raised to x divided by x plus. Here integral e raised to x into 1 plus x divided by sec of x into e raised to x dx is asked. Integral e raised to x into 1 plus x whole divided by sec of x e raised to x is what is asked in the question. Okay, so if you look at this, we can easily say x e raised to x derivative is going to be e raised to x into 1 plus x. So I will first put u is equal to x e raised to x. Okay, so naturally du will be equal to x into e raised to x plus e raised to x into 1, which is chain rule of differentiation, sorry, product rule of differentiation dx, right? So I can actually replace x e raised to x plus e raised to x as e raised to x into x plus 1 into dx, right? So that is equal to du, which means this integral changes to numerator completely becomes du whole divided by sec of u. Okay, now 1 by sec of u is actually cos of u, so cos u du, right? And the integral of cos u du is minus sine u, sorry, not minus sine u, plus sine u plus c. Okay, now you can replace u by the function x e raised to x, which means that is sine of x e raised to x plus c. So the answer to this question is option A. In this question, the integrating factor of the differential equation dy by dx minus y by x equal to sin x is asked. So when you consider this equation in the form of linear differential equation dy by dx plus py equal to q of x, we know the integrating factor corresponding to this equation is e raised to integral p dx. Okay, now when you compare it with this the given equation, you know p is actually equal to minus 1 by x, correct? So what is the integrating factor? Integrating factor will be equal to e raised to integral minus 1 by x dx, right? So that is equal to e raised to log, sorry, minus log x dx, right? So that is e raised to log of x to the power minus 1, right? There is no dx here, which is equal to e raised to log of 1 by x, and e raised to log of any function is that function itself, so the answer is 1 by x. So option C is the correct answer.